You have to write down the mechanism for this reaction. So product is given to you. You have to tell me the mechanism. So you have this peroxide effect. So this reaction is something related to peroxide effect, ROOR. And this gives you Br attached at this carbon, and a hydrogen gets attached to this carbon. I am not showing you the hydrogen. You have to give me the mechanism. So what is the steps? So I will give you a hint. The first step is generate an electron, a radical. In the next step, so try this one. I will give you a hint. Generate an electron radical, then abstract a hydrogen H dot, generate Br dot, attack Br dot, and then again abstract a hydrogen. Let us take 1 minute time. Okay, I think some of you may have done. So first step is simply generation of radical ROOR. If you heat this one, so you will have one electron go this side, one, so you will have 2 RO dot. These things we have discussed in details in class, so I am going to slightly go fast. And now this RO dot can take hydrogen from HBr. So one electron goes here, one electron goes here, one. So you will have ROH plus Br dot. So basically you have generated the Br dot. Br dot will act as the electrophile. Now third step, you have this alkene, and on this alkene Br dot will add. So if this Br dot adds, I should add at this position or this position. If I add this position, I will get a tertiary radical. So I will have to have at this position, because tertiary radical is more stable than secondary radical. Now the next step, I have to take one hydrogen and regenerate. So if I take HBr, what will happen? One hydrogen electron and one electron from here comes, this goes here. So you will have this Br, are you getting? And plus Br dot. So you have regenerated the Br dot. So this is regenerated. Are you getting? Now these two steps are basically propagating steps. So these are propagating steps. And the upper one is basically chain initiation step, and one is radical generation step. So the first one is radical generation step, second one is chain initiation step, and third, fourth are propagation step. Basically I am not interested in the top two steps. You see, important point in this case, Br dot is acting as electrophile. So in the first step, Br dot is acting as electrophile, and hydrogen gets added in the second step, and that's why you have a Antimarkonikov addition. If you have HCl, in that case H plus is added in the first step, Cl minus adds in the second step. But here you have Br dot that is adds in the first step, H dot that it adds in the first step. Radical, in this case you will get radical as intermediate. In this case you will get carbocation as intermediate. Of course, the same factor that stabilizes the carbocation also stabilizes the radical. So if you consider the factor, you can be confused. Why I am getting a opposite product? Why I am getting Antimarkonikov? This is because in one reaction H dot is attacked in the second step. In another reaction H plus is attacked in the first step, and that's why we have the two different product. Okay, let us copy this one and then we will discuss the next problem.